Good evening.
So, recall. I hope my voice is audible, sir.
Yeah. Yes.
Screen is visible.
Screen is visible. Voice is very clear, madam.
Right. Thank you, sir. So, recall. In the previous class, we have studied what is a series. So, corresponding to a sequence un 1 to infinity, we can always have a series. This means u1 comma u2 comma and so on up to un comma and so on. Corresponding to this sequence, we can define a series n equal to 1 to infinity, that is u1 plus u2 plus un, there is no end, and so on. This is called as the sequence series corresponding to the sequence un. So corresponding to sequence un. Then question arises, when is this series set to be convergent? When is sequence set to be convergent? We have done earlier. The sequence will be convergent if limit n tending to infinity of the sequence is finite and unique. Finite and unique. And is divergent if limit divergent if this limit of this is infinity or minus infinity. So, and oscillates finitely if limit is finite and unique, finite and not unique. And this is going to oscillate infinitely if we get both infinity and minus infinity. Limit is if this limit is infinity and minus infinity. Sometimes infinity, sometimes minus. Okay, this is what we study. Now we want to know what about the series. This is about sequence. How about the series? So the question arises, if the sequence un is convergent, can we say the series is convergent? Answer is need not be. Then how do we test first of all? So for that we went for a concept called nth partial sum to find out whether the series is convergent or not. So for a criterion for series to be convergent, or divergent or oscillating, we want to know the nature of this. So for this, we consider nth partial sum. It is denoted by Sn. S1, U1 plus U2 plus and so on up to n. Sum, S for sum of first n terms. S1 means U1. S2 means U1 plus U2. S3 means U1 plus U2 plus U3. Sn means sum of first n terms. So then, if the sequence formed by this nth partial sum, this forms a sequence. If the sequence formed by this nth partial sum, that is the sequence, if this is convergent to L, when do we say it is convergent? If limit is finite and unique. and unique, like we did for sequence. This is a sequence. If the limit is finite and unique, then we say if the sequence is convergent to L, then we say the corresponding series is also convergent. Also convergent. L. And summation un is equal to L. N equal to 1 to infinity will be equal to this limit. That is u1 plus u2 plus and so on up to infinity will be equal to un will be there. It will continue up to infinity is equal to L. Okay. Now, if the sequence is divergent, if the sequence not un Sn is divergent, then we say the corresponding series is divergent. And if the sequence is oscillatory, oscillates finitely, then the corresponding series is also corresponding series summation un oscillates fine. And if the sequence Sn oscillates infinitely, then summation un oscillates infinite. This is the concept. So we have done one question also based on this. Now we want to know, for example, we want to apply this concept. Is the series 1 plus 1 by 2 or 1 by 2, 1 by 2 square, and so on, or 1 by 2, let us start with this, plus and so on. Convergent. We want to know. And also, we want to know the series 1 square, 1 plus, 4 plus, 9 plus is convergent. We want to know 1 by 1 into 2, 1 by 2 into 3, and so on. Is this convergent? And also we want to know 1 minus 1 plus 1 minus 1 convergent. We want to. So let us see these questions. We'll follow nth partial sum. Later we'll go for some other methods. Let us apply original method. 1 by 2, 1 by 2 square, and so on up to 1 by 2 power n and so on. So what is the procedure? First we have to find the nth partial sum. So this is 1 by 2, 1 by 2 square, and so on 1 by 2 power n plus and so on. So this is a series n equal to 1 to infinity 1 by 2 power n. We want to know whether this is convergent. Original procedure is first we must find nth partial sum. First term, second term, up to nth term. No, there are n terms. How to find the sum of n terms? This we have to simplify. This is in the form A, AR, AR, and so on, AR power n minus nth term. A is 1 by 2. R is 1 by 2. So A is 1 by 2, geometric progression, R is 1 by 2. We want to find the sum to n terms. What is the formula? 1 minus R power n by 1 minus R. Then this is 1 by 2, 1 minus 1 by 2 power n by 1 minus 1 by 1 minus 1 by 2 is 1 by 2. So this is 1 by 2, 1 minus 1 by 2 power n by 1 by 2. Cancels. So 1 minus 1 by 2 power. Now this is SN. We want to know whether this sequence whose nth term is this is convergent or not. How to know whether this is convergent or not? To know whether the sequence is convergent or not, the sequence formed by this, we have to find limit S. How to find limit of the sequence? Limit of the nth term. That is limit n tending to infinity 1 minus limit n tending to infinity 1 by 2 power. This is 1, this is 0. Because limit R power n is 0 if mod R is less than. Here R is 1 by 2. It is less than. So, which is finite and unique. We are getting only one limit. Finite, unique. Therefore, sequence Sn is convergent. Because this is convergent, this converges to 1. This is our L. We say summation un 1 by 2 power n also converges to L. Moreover, this summation un 1 by 2 power n 1 by 2 1 by 2 square is equal to L, which is so this is how we check. But this is lengthy procedure. There are shortcuts which we are going to see in future. But shortcuts will not work for all. So you should know the original procedure. All problems cannot be done using any test. Basic definition is very important. 1, 4, 9 and so on. Is it convergent? We have to test. So how to test again? First we must find. Sometimes some questions can be done using only this test. So summation un is 1 plus 4 plus 9 plus and so on. This is 1 square plus 2 square plus 3 square plus and so on. N square plus and so on. So first what you should do? Sn we must find. 1 square, 2 square, sum of first n terms. All of you know this is nothing but summation n square. You might have studied this. What is the value? You must be knowing. What is this value? N
n
into
into n plus 1 into 2n
n plus 1 into 2n plus 1 by 6.
6.
So now we have to formulate the sequence whose nth term is this. This is the nth term for one sequence. If you put n equal to 1, you will get S1, n equal to 2, S2 and so on. Now we want to know whether this sequence is convergent or not. How to know? Limit of the sequence is limit of the nth term. So limit n tending to infinity 2n plus 1 by 6. So n common, n cube. As n tends to infinity, this is infinity. 1 plus 0, 2 plus 0. So this is not final. Therefore, the sequence Sn diverges. Therefore, the series Un, which is 1 plus 4 plus 9 plus and so on, also diverges. So if the sequence is convergent, the corresponding series is convergent. If the sequence is divergent, the corresponding series is also divergent. Not Un, Sn. Let us see 1 by 1 into 2, 1 by 2 into 3, such sequences. How to work out? Third one. The series is 1 by 1 into 2, okay, 1 by 2 into 3, and so on. We have to find the nth term. So what is the nth term of this series? 1 by 1 into 2, 1 by 2 into 3. This can be rewritten and so on. What is the nth term? 1, 2, 3. Nth term is n. Second terms, the difference is 1. First term is 1. First terms 1, 2, 3, and so on. So nth term will be n. Second term is 1 more than this. So
N plus 1.
Plus and so on. If you put n equal to 1, you should get back first. You can cross check. So then we have to find a Sn. 1 into 2, 2 into 3, n into n plus. Then this is nothing but 1 minus 1 by 2. Because 1 minus 1 by 2 is 1 by 2. 1 by 2 minus 1 by 3. Take LCM, 3 minus 2, 1 by 2 into 3. 1 by n minus 1 by n plus. So, because if you take LCM, simplify, you will get back. Now, we have to, when you observe what is Sn is, our observation is, second term is cancelling with the next term first term. This will cancel with the next term. So, all the second terms are cancelling with the next term. This first term is cancelling with the previous term. So this 1 by n will cancel with the previous one. What will be previous one? 1 by n minus 1 minus 1 by n. So in this, the second term is cancelling with the previous first term. This is cancelling with the next one. For this, there is no next term to cancel. So what remains is this. Now we have to formulate the sequence formed by this. This is nothing but 1 minus 1 by n plus 1. Now limit of the sequence is limit of the nth term, which is limit 1 minus 1 by n plus 1. As n tends to infinity, 1 by infinity minus plus 1 is infinity. 1 by infinity is 0, which is finite and unique. Therefore, we say that it is convergent. If this is convergent, converges to L. L is 1. Therefore, the corresponding series is also convergent. It's convergent. Not only that, the sum is nothing but equal to L. Summation Un will be equal to L, which is, that is 1 by 1 into 2, 2 into 3, summation n into n plus 1. What is the value? You can find in many papers. The value of this is, it's nothing but very interesting. Then remember this as formula, or you have to do like this. So you are getting definitely one question. Whatever is the entrance examination, including your JL, DL, anything, definitely you are getting one question. What is the value of this? It is convergent, correct? What is the value? Using your nth root test, ratio test, you can know whether it is convergent or not. But what is the value of that? That you will know using this. This is what we have seen. One more is left over, that will see. What is the next question that's left is 1 minus 1, 1 minus 1 and so on. This is the next series. So let us see. So you must learn this procedure because some questions which cannot be done using any other test in future can be done using only 1 minus 1, 1 minus 1. Questions like this, U1, U2, U3, U3 plus U3, minus U4, and so on. Then, what will be your S1? We must find. S1 is 1, U1. S2, U1 plus U2, 1 minus 0. S3, U1 plus U2 plus U3, 1 minus 1 plus 1. S4. One minus 1 plus 1 minus 1, which is 0. So for all odd suffixes, we are getting 1. For all even suffixes, we are getting 0. So, and so on. What will be your Sn? It will be 1. If n is odd, it will be equal to 0. Then it's even. Therefore, what can you say about the sequence formed by this? We want to. So find out limit of the sequence. What will be the limit of the sequence? It's nothing but limit of the nth, which will be limit 1 if n is odd, and is equal to limit 0 if n is even. Therefore, we say that summation un is, what can you say about the sequence? Limit is finite but not unique. Sometimes 1, sometimes 0. So the sequence oscillates 5. Because limit is sometimes 1, sometimes 0, finite but not unique. So oscillates finitely. Therefore, the corresponding series also oscillates 5. That means not convergent. Is it convergent or not means? In particular, not convergent. Not convergent means it may be divergent, it may oscillate finitely, or it may oscillate infinitely. It's not convergent. Summation un is not convergent. This is how we test. But this much procedure, what we observe is, luckily or unluckily, we are able to find out this Sn, some term, it is following a systematic pattern. So we are able to predict the nth term. Suppose you are not able to find out your Sn, in that case, we cannot proceed further. So if you are able to get a formula for Sn, that is sum of that if you are able to find, then only this methodology works. Otherwise, this will not work. This works for
Ma'am,
all types of series. Here we observe this here. What we observe is here all are positive. This is called positive term series. Here also, all are positive. All are positive. That is U1, U2, U3, UN. Such series here also. Here also. All these 1, 2, 3, they are called positive term series. Positive term series. And when you look at 1 minus 1, 1 minus 1 something, this is what is called alternating series. Because we are having alternatively plus minus, this is called alternating series. Okay. So this methodology of nth partial sum is valid whether it is positive term series or alternating series. In all cases, this is valid. Now we want to find out an alternative. All questions cannot be solved using this methodology. So we want to go for next. This is basic concept.
ma'am, when I have one question, ma'am.
Amma?
One question, ma'am. One problem like this. I, sigma
One problem?
UN, not this one, ma'am. I have one question. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, like that, up to 1 by n
That
plus
we'll see using
infinity.
some other methodology.
Okay.
Here using this we cannot find out. Because what is the value of Sn? 1 plus
That,
1 by 2 plus 1 by 3 plus and so on up to plus 1 by n. Is there
yes.
any formula to
No.
find nth partial sum? What is Sn? Can we write this as something? Had it been 1 by 2 square, some formula we have seen. This, what is this sum? Unless we know, we cannot proceed further using this method. So we go for this using auxiliary series test. This is
Yes.
very good. So we go for some other methodology. All you cannot get using this. That's what I am saying. All problems cannot be solved using this. One of them is this is the best example. Sarita has given. This is the one. For this, you cannot apply this method. You need to go for next alternate method. Because we don't know what is this value. Had it been 1 plus 2 plus 3 and so on, summation n. So like that, if you have formula only, you can do. If you cannot segregate it, you cannot consolidate into a formula, a term, we cannot do this. So we go for next method. I will try to work out using auxiliary series. That you remind me there. So now we go for some other technique. So the technique for this is called necessary condition. So all of them are not convergent, some are divergent. So by looking at them, can we say? That is the next question which we should answer. What is your problem? You are writing entrance, not descriptive paper. For your SEM exam, this much, doing this much, okay. Amma.
All doubts, madam. -1 whole to the power of n. If the ten is equal to even, n is equal to odd. 1 is -1 plus 1 like that. But in limit intention infinity.
Entama, cheppu. What is your problem? Somebody said, okay. So necessary condition.
Is it audible, madam?
Yeah, now audible. What is your doubt?
-1 whole to the power of n, madam. Once again, ఒకసారి repeat చేయరా మేడం ఇది?
చెప్పమంటున్నారా? Okay. Okay, fine. Here, summation un. This is not -1 power n series, sequence. It is a series. This is u1. This is u2. I can call it u1 minus u2, saying u2 1. Or I can say u1 plus u2, and say u2 is minus 1 in any case. So plus u3 minus u4 once. This is called alternating series. Alternatively plus minus we are getting. But this methodology is applicable for all positive terms or alternative plus minus also. What is the methodology? We have to find Sn. So first we'll try to predict because we cannot find directly. We are finding S1. What is S1 means? U1, 1. Previous class we discussed. What is S2 means? Sum of first two terms. What are you getting? U1 is 1. U minus U2 is minus 1 means U2 is. Acha, here she got doubt. U1 is 1. U1 plus U2. Yeah. 1 minus 1. First two terms. Sum of first two terms. Sum of first two terms. I will not call it as U1 minus this one. I will call it as S2 because we are getting all these doubts. Just
Okay, madam. Okay.
yeah. I will remove this if you are getting doubt, because the doubt which she got you may get again. Symbols problem. Problem is with symbols. So yeah, good doubt. Good doubt. So then this is S2 means sum of first two terms. Don't call it U1 plus U2 or something. First term is 1, second term is minus 1, sum of first two terms. S3 means sum of first three terms. Sum of first two terms. Name can be anything. First two terms. Sum of first three terms. First three terms. So first one is 1. First two terms, sum 1 minus 1. Sum of first three terms 1 minus 1 plus 1, 4 terms. I think it's okay. And so on. What will you get? Sn? Either 1 or 0. So, okay. Sum of first 4 terms. Whatever may be the terms. Okay, Nama. Now, did I clear your doubt?
Okay, madam.
All right. Now, what is the necessary condition? Necessary condition for series to be convergent. You may get theoretical question again. Series, for series summation un to be convergent is limit un is equal to 0.
0.
This is called necessary condition test. What is the meaning? It helps negatively than positively. What is the meaning is summation un is convergent implies limit un is 0. That's what is the meaning of this statement. That is, don't understand like this. If limit un is 0, you cannot say it is convergent. Converse is need not be true. But if it is convergent, definitely limit will be 0. In what way it helps us? So it is of no use for us. This is in the form P implies Q. If P, then Q. If un is convergent, summation un, then limit is 0. It is in the form P implies Q. It may not help us, that is positively. It helps negatively. P implies Q. You have done discrete mathematics and set theory. This is same as equivalently implies negation P. That means whenever this is true, this will be true. Whenever this is true, this will be true. This is called contrapositive of the statement. Contrapositive statement. So what is the equivalently? Q means this, P means this. Negation Q. Negation Q means if limit un is not 0, negation for equal to 0 is not equal to 0, then summation un is not convergent. So summation un is convergent implies limit un is 0, p implies q. Negation q implies negation p. That is, limit un is not 0 implies negation p, summation un is not convergent. This is necessary condition. This helps us. So given any question, to know whether it is convergent or not, find out the limit. If the limit is not 0, then it is not convergent. If it is 0, don't conclude anything. No conclusion. If it is 0, we cannot say anything. Don't conclude convergent, divergent. You need to go to next step. Next step means some test. So using this, we cannot conclude. So what is the methodology? Very interesting point. Method 1. Method 1 already we have seen using original method. Method 2 is find limit un. If it is 0, not equal to 0, then conclusion, not convergent. Not convergent does not mean divergent. Please, it may oscillate finitely, infinitely, and so on. Some students will be thinking not convergent means divergent. Among options, you will be given not convergent, not divergent, divergent, none of this. So, majority of the students, they conclude not convergent, divergent, both will be there. So, some students, they will conclude divergent because they think not convergent means divergent. We don't know. If student not passed, it does not mean failed. Must have been malpractice or withheld, anything. Not passed does not mean failed. May come under any one of the other options. Similarly, if limit is not 0, then it is not convergent. Definitely. What is it? We don't know. We need to go to next step. Okay, don't conclude divergent. But if it is a positive term series, if u1, the series is summation un is in the form positive term series, all are positive. That is u1 positive, u2 positive, and so on, all are positive. Sign also positive. Then it is called positive term series. Then this series is positive term series. If it is positive term series and the limit un is not equal to 0, then two conclusions you can draw. One is summation un is not convergent, correct? Not only this, you have more than one correct. One more is summation un is divergent. Very interesting. When can you say not convergent means divergent? Provided the series is positive term series. If all are positive terms, if alternatively plus minus is there, you cannot say it is divergent. It may be oscillatory also. For example, 1 minus 1, 1 minus 1, it is oscillatory. So, if all are positive term series, then not convergent means divergent. That is, not convergent implies divergent. When, if it is positive term. If it is alternating series, you cannot say. Okay. So this is the conclusion. So among options, not convergent will be there, divergent will be there. Both are correct options in case of positive term series. In case of alternating series, u1 minus u2 plus u3 minus u4, in that case, if limit un is not 0, then we have to say only it is not convergent. Don't conclude divergent. That's what I mean. This is the test. Let us do. And one more test is there. That helps you a lot. But before going to that, let us do some questions based on. Sometimes it is very easy. You'll be searching in the sky, but it will be on the ground, the answer. So you'll be applying directly to D'Alembert ratio test, Cauchy-Centru test, something higher. Like you prepare for CSIR exam. You prepare something in the sky. But questions will be from the base. Always any entrance exam. They want to test you not in the unknown area. Because nobody can touch the sky. Nobody can say, I am perfect in this subject, in this topic. Real analysis, if you take only to certain extent, we know. We are better than you, that's all. If you go depth into the subject, in the research orientation, no one can come out of that. There are so many lanes inside. We will know only one lane inside. That's it. Our lifetime will be sufficient. For our lifetime, we will know only one lane. But topic తీసుకుంటే అది నాకు తెలుసు 100% అని ఎవరు చెప్పలేదు. అది వెళ్తూ ఉంటే డెప్త్ వస్తూనే ఉంటుంది. ఎవరైనా పిహెచ్డి చేస్తున్నారు, గైడ్ చేస్తున్నారు, ఓన్లీ ఆ టాపిక్లో. అందులో కూడా మళ్ళీ చాలా రకరకాలు ఉన్నాయి. ఫ్లూయిడ్ డైనమిక్స్లోనే బోల్డ్ అని ఉన్నాయి. సో ఇన్ వాట్ ఎవర్ మెథడాలజీ దే హ్యావ్ డన్ ఇన్ దట్ స్మాల్, with respect to which they have done research, only with respect to that component they can say they know. Not totally that too, a little bit. But it is ocean, subject is ocean. So we cannot say the total. So in this case, how will we know whether it is convergent or divergent? Is basic definition sometimes. We cannot reach top, but we can stand on the earth and check. So the basic is this. So first you check this. If it is not working, only go for other methods. My sincere advice. Okay, so let us see. Which of the following are converge or not converge? How to know which is not convergent? Limit you find out. If it is not 0, limit of the nth term, automatically it is not convergent. For example, very interesting questions. Cos 1, cos 1 by 2, cos 1 by 3, cos 1 by n. You apply any method, it is not possible to solve this using other techniques. Using only this you can. So what is this? How to check? This is nothing but cos 1 by n. This is summation un. Un is cos 1 by n. What is limit un? We have to apply this test. Limit n tending to infinity un. Limit n tending to infinity cos 1 by n. As n tends to infinity, 1 by n will go to 0. Cos 0 is 1, which is not 0. Therefore, summation un is not convergent. Not only that, it is positive term series. Therefore, you can conclude it is divergent also. So, as summation un is positive term series, we can say summation cos 1 by n not convergent also implies it is divergent. So among options, you may be given not convergent, that is also correct. Divergent is also correct. So very interesting. Summation cos 1 by n is divergent. You apply 100 methods, difficult. Now easily we can. Next. For certain questions, these methods are very easy. Second question. Root 1 by 2, 2 by 3, 3 by 4, and so on. Is it convergent or not? We want to know. So what is the nth term? This is nothing but summation un, which is equal to summation. What is the nth term? You see numerators. All of them are having root. Numerator, first term 1, second term 2, third term 3, nth term will be n. Denominator is 1 more than numerator, n plus 1. So if n is 1, this is 2. If it is 2, it is 3. 1 more than numerator. Now we want to know whether this series is convergent or not. So for this, we apply preliminary test. So limit un is limit root n by n plus. How to find out this? Divide by n. 1 by 1 plus 1 by n. N by n is 1, n by n is 1, 1 by n. As n tends to infinity, 1 by n is 0. This is 1. 1 plus 1 plus 0. Root 1 is 1. We take only positive. It is not 0. And therefore, the series is not convergent. Is not convergent. So apply such simple methods for concluding. If they're all positive terms, so you can conclude divergent. Next. Cos 1 by n square. Cos 1 by n we have done. What can you say about cos 1 by n square? So let us see. This is summation un. So un is cos 1 by n square. So find out limit. Limit n tending to infinity, cos 1 by n square. As n tends to infinity, 1 by infinity is 0, cos 0 is 1, which is not 0. Therefore, we can say summation un is not convergent. Not convergent also means here divergent because it is positive term series. Or you can also conclude divergent because it is positive term series. Positive term series. So summation cos 1 by n square is divergent. Is not convergent, correct? Divergent is also correct. So, not divergent. It is also divergent. This is also one more conclusion. Based on the options, both are there, both are correct. Next. So we want to apply this. What can you say about sin 1 by n at present? Suppose somebody must be having interest. So this is summation un. Un is sin 1 by n. Limit un. Limit as n tends to infinity, 0. So don't conclude convergent. Don't conclude divergent. Needs no conclusion at present. No conclusion using this test. For this, we apply limit comparison test in future. There we will conclude this is convergent or divergent. We will know using that test. Needs further investigation. Needs further investigation. That is, apply some other test, suitable test. Needs further investigation to conclude. We don't know. It may be convergent, it may be divergent. We don't know. We need to go to next test. Go to next test. What is that? We'll see later. Question. This is 1 to the power of 1 by 1. 1 by 2 to the power of 1 by 2. 1 by 3 power 1 by 3. So That is, the question is 1 plus 1 by 2, 1 by 3 power 1 by 3, like this. It may be given like this. Or it may be given in another format, root 2, cube root of 3, and so we want to. So how to know this? First we have to find out nth term. So what is summation un? What is the nth term? For first term, 1 power 1 by 1. Second term, 1 by second term, 2 power 1 by 2. Third term, 3 power 1 by 3. Nth term, n power 1 by 1. You may be knowing summation 1 by n whole power 1 by n. You also mean this. So either it will be given like this, or like this, or like this. Then how to know whether it is convergent or not? Find out limit union. Nth root. You know, limit n power 1 by n is 1. We have done standard limits. Limit n tending to infinity. N power 1 by n. Standard limit is 1. So it is not 0. Therefore, summation un is not convergent. Can also say divergent because it is positive terms. Not convergent correct, divergent is also correct in this case. Another interesting question. Test the convergence of summation root of 3n square plus 5n plus 4 by 4n square plus 1. Nobody does all this. You will be knowing directly limit comparison test, Cauchy's nth root test, ratio test. You directly jump to them generally. Maximum you will do geometric series test and auxiliary. But questions based on them are coming in the entrance. So this is based on you apply any one of the another test. Some questions may not be solved. You cannot solve using any one of them. Some can be solved using that technique as well as this. But some questions specifically can be solved easily using this. So you can see such a big term. This is nothing but summation un. Easily can solve using preliminary test. So limit un. What is un? 3n square root of 3n square plus 5n plus 4. So what is limit un? Four n square plus 1. So as n tends to infinity, divide by n square. 3 plus 5 by n, 4 by n square, divide by n square. 1 by infinity 0, 1 by infinity 0, 1 by infinity 3 by 4. Not so. Therefore, summation un is not convergent. Can say divergent. Positive term series. Next. Another interesting, given in many papers. All these questions you can find in some paper or the other. Students, they struggle a lot for some questions, but they're so simple. Repeatedly given in many papers. This is summation un. We want to know whether they are convergent or not. They go to ratio test, this, that, wasting time. But using preliminary test, you can come. So this is limit union. How to find out? Divide by n square. 1 minus 0. Therefore, it is not convergent. Moreover, divergent because it is positive term series. It's not convergent. You can also conclude divergent directly, given in many papers. This is there among options, okay. Divergent is also correct because it is positive term series. Next one. Summation, another interesting question. N by 1 plus 2 power minus n. Typical questions. So, in this case, this is summation un. Un is n by 1 plus 2 power minus n. You can rewrite it as n by 1 plus 1 by 2 power n. So what is limit un? Limit n tending to infinity n by 1 plus limit n tending to infinity 1 by 2 power n. Here there is no n, so it is itself. This is infinity. 1 plus limit of 1 by 2 power n is 0 because limit r power n is 0 if mod r is less than 1. So here r is 1 by 2. So mod 1 by 2 less than 1. Infinity by 1 infinity. So limit un is infinity, which is not 0. Therefore, summation un not convergent. Can also sing divergent because it is positive term series. So last in this model, there are many. You take any text and try to do. I'm doing only typical questions. 2 by minus 1 power n minus 3 whole power n. Typical question. So as I said earlier, whenever you have minus 1 power n, always divide into two cases, even, odd, always, wherever it is, whether it is sequence or series. So, solution. Your un is 2 by minus 1 power n minus 3 whole power n. This is your un, summation un. So, divide. So, minus 1 power n is 1, n is even. So, in every case, it should be convergent. Then only we say overall it is convergent. Any one case it fails, we cannot conclude. So, what is un? 2 by, if n is even, it is 1, 2 by minus 2, minus 1 power n. Minus 1 power n as n tends to infinity. What is the value of this? First you have to simplify, then apply. I'll come back to this. And if n is odd, it will be 2 by minus 1 minus 3. N is odd. 2 by minus 4. Minus 1 by 2 whole power. If n is odd. So, un minus 1 power n if n is even. If n is even, I'm sorry, if n is even, what is minus 1 power n? It is nothing but 1 itself because n is even. And n is even. If n is even, this is 1. This is the case 1. if n is even. If n is even. So what is the conclusion? 1 itself if n is even. Minus 1 to the power of even number is 1. So we got un as 1 if n is even, minus 1 by 2 whole power n is odd. So we have to find limit. What is limit un? Limit n tending to infinity 1, which will be equal to 1, which is not 0 if n is even, and is equal to limit minus 1 by 2 whole power n, which will be 0 because limit r power n is 0 if mod r is less than 1. Here you can see r is minus 1. This is if n is odd. Here minus 1 by 2 modulus is plus 1 by 2 less than. Mod r less than 1, then limit r power n 0. Therefore, limit un is not 0 if n is even, 0 if n is odd. So you will be given some conclusions. So summation un not convergent when n is even, convergent if n is odd. Like this, options will be given to you. And overall, for all n, what can you conclude? So if it fails in any one of the cases also, it is failure. Therefore, we can conclude 2 to 3 things. First conclusion. So among options, you may find any one. Summation un not convergent. Not convergent if n is even. And there is a second conclusion. Summation un is not convergent overall. Because if it fails in any one of the cases, it is not convergent. Next. Number 3. When it is odd, you are getting 0. If you get 0, don't conclude convergent. Maybe convergent. So you need to do further investigation. Then only we can conclude. Go for next test. Any one of the suitable test. Suitable test. Then only we can conclude. Okay. So this is how we will solve the questions based on this. Try to work out from previous papers questions based on this. Then we have another concept, shortcuts. As I said, we will go for now positive term series. Here we divide. Till now we have applied both the tests, partial sum test, and this for both the type of series. That is alternating series as well as for positive term series. So what is alternating series? Alternating series. So we applied for both. Means u1 minus u2 plus u3 and so on. This is called alternating series. That is 1 minus 2 plus 3 minus 4. This is example. 1 minus 1 plus 1 minus 1. That is also an example. Next, positive term series means. So how to test for them? This we'll see towards end. The convergence and divergence of this will be tested. First preliminary test. Whenever there is ambiguity, if it is 0, go to alternating series test. That we'll discuss later. Now, at present, our topic is under discussion is positive term series. So, when is it convergent? We are going to discuss now. So, positive term series means U1 plus U2 plus U3 plus and so on. Where U1 is positive, U2 is positive. These are all positive term series. Positive term series. Okay. Now, there are shortcuts. First method is called geometric series because these methodologies using this preliminary test, sometime if it is 0, limit is 0, we are not able to say anything. Is it convergent or not? If limit is 0, we don't know. It may be convergent. Maybe convergent means maybe convergent, maybe divergent. But if it is not 0, definitely not convergent. If it is 0, we don't know. Then how to break the ambiguity? You have to go to next test. If it is 0, go to any one of these tests. Not 0, stop. Conclude, not convergent. So this is the third method, method 3. Geometric series test. That is summation r power n. That is 1 plus r square plus and so on. Converges. If mod r is less than, if r is less than 1. Diverges. If r is equal to 1 or greater than 1. So I'm not taking negative terms, all are positive. So positive term series, that's the reason I'm not taking modulus r less than 1. Alternatively, we'll discuss later. R less than 1 or greater. So if it is in this form, if r is less than 1, convergent, r greater than 1 or equal to 1, divergent. What is the application? Application is, for example, 1 plus 1 by 3 plus 1 by 3 square plus and so on. Is it convergent or divergent? So when you look at it, r is 1 by 3, 1 plus r square and so on, which is less than 1. Therefore, the series is convergent. If you take limit 1 by 3 power n, it is 0. This is nth term is 1 by 3 power n. If you take limit, 1 by 3 power n will be 0. So using previous test, we cannot solve this question. We will know it may be convergent. Then how to break that ambiguity? Maybe means it may be convergent, maybe divergent also. So how to break the ambiguity is, we go for this test. If it is in geometric series form, 1 plus r square plus and so on, this series is called geometric series. Okay, next one. Let us go for another question. 1 plus 4 plus 8 plus and so on. So this is in the form 1 plus 2 square plus 2 cube plus and so on. So here r is 2 greater than 1. A is 2 r 1 plus. You can also add 1 plus 2 plus 2 square plus and so on. You can have. Even if it is 2, you can take one common and apply, of course. This is 1 plus r square plus r cube plus and so on. Here also, even if 2 is there also, no problem. A plus AR plus AR square plus, in that case also, R is what is R important. So in this case, greater than 1, therefore the series is divergent. Equal to 1. 1 plus 1 plus 1 plus 1. Yesterday we have seen R is 1. How to find R? Second term by first term. Third term by second term. R is 1. So divergent. Yesterday we have seen this. The sequence converges. The sequence converges. Why it converges? Because what is the nth term? 1. Limit 1 is 1. Finite, unique. So convergent. As a sequence it converges. But as a series, diverges. Very interesting. Because some students will be thinking sequence convergent means series convergent. No. Next. Let us go for now another test, which is auxiliary series. So whenever you get limit un 0, you need to apply any one of these tests. Or it is also called P test. What is it? Summation 1 by n power p converges. P is greater than 1. Diverges. P is less than. You can go through the proofs. Wonderful proofs are available in any text. But our context is not that. So we want to know when is it convergent. So let us see. It is convergent if it is less than 1. Divergent if P is less than 1. So for example, the question which Sarita gave today. Is this convergent? Which she gave. We could not solve using that nth partial sum, because we don't know what is the value of 1 plus 1 by 2 plus 1 by 3 plus and so on 1 by n. So we cannot conclude using first method. What is the nth term? This is nothing but summation 1 by n. Nth term is 1 by n. So limit un is 0. 1 by infinity is 0. So using necessary condition test also, we cannot conclude. Maybe convergent. Limit un is 0. So it may be convergent. Maybe. Maybe means maybe may not be. So how to break the ambiguity? We have to go for this auxiliary series test. Simplest test, which most students, they like this. Compare. P is 1. If it is less than 1 also, divergent. Equal to 1 also, divergent. Summation 1, diverges. So 1 plus, 1 by 2 plus, 1 by 3 plus, diverges. If P equal to 1, it diverges. Summation 1 by n diverges. But limit un 0, you can see. That is the reason why if limit is not 0, not convergent. But if it is 0, it may be convergent, may be divergent sometimes. So not convergent. In this case, may be convergent. Maybe there is a chance. Sometimes maybe, sometimes may not be. For example, here we got it as divergent in spite of limit un 0. That is the reason why it is only necessary test, but not, it is not a sufficient test. Necessary and sufficient means you can apply both the sides. Okay? This is the summation 1 by n. if you take, for example, another one, 1 plus 1 by 2 square, 1 by 3 square, all of you know this, very simple. So if you take, this is nothing but summation 1 by n square un. What is un is 1 by n square. So what is limit un is 0. Therefore, it may be convergent, may be divergent, summation un. But how to break the ambiguity? Using auxiliary series test. So summation 1 by n square is 1 by n power p. P is equal to 2 greater than 1. Therefore, summation 1 by n square converges. See, here also limit is 0. It is convergent. Here also limit 0, but it is divergent. Therefore, when limit un is 0, it may be convergent, may be divergent, depends on the question. Okay, this is one of the best applications of this. Next, we have some tests, like somebody may get a doubt. Madam, summation un converges, summation vn converges, then what can you say about un plus vn? Like that. So, summation un, if summation un, comma summation vn converges, then un plus vn converges. For example, you may be given a question. What can you say about directly? Questions will not be given. Indirectly, they will be given. Is this convergent? So if you refer 100 textbooks, also answer will not be there. Common sense, properties. So whenever sum is given, test individually. If both are convergent, then the series is convergent. If at least one of them, any one of them is divergent or both are divergent, it is divergent. Very important. So this is convergent. And if constant is there, constant times convergent series is convergent. So is this convergent or not? Means yes. Answer is yes. Because summation 1 by n square, 1 by 2 power n is in which form? un plus vn. What is un is 1 by n square. Vn is 1 by 2 power. Summation un. It is in the form 1 by n power p. P is equal to 2 greater than 1. Therefore converges. Converges by p test. But summation vn 1 by 2 power n is in the form r power n. R equal to 1 by 2. Less than 1. Therefore by geometric series test converges. Summation un converges, summation vn converges. un plus vn converges. Therefore, 1 by n square plus 1 by 2 power n converges. So we can also write it as converges. So like this, you can apply algebra and then do it. If any one of them diverges, series diverges. So that is again next one. Summation un plus vn diverges if any, at least one. At least one means either any one or both. Any one. At least one of them. What is the example? What can you say about summation 1 by root n? In this case, it diverges. Why it diverges? What can you say about this? Solution is divergence. Why is it so? Summation un is 1 by root n, 1 by n power 1 by 2, p is equal to 1 by 2, less than 1. Therefore, summation diverges. Summation Vn 1 by 3 power n converges. So this is how we apply for this. So let us go for. So tomorrow we are going to see, not tomorrow, in the next class, we are going to apply this and find like what is the value of n into n plus 1 into n plus 2. What is the value? Definitely you are getting some questions like this. So how to find them? You are thinking, you are applying for this. Some students, they are directly going for limit comparison test. Using limit comparison test, you will know whether it is convergent or divergent. That's it. What is the value means? You are not able to calculate. But definitely you are getting questions in the entrance asking you to find 1 by 1 into 2 into 3, 2 into 3 into 4, something like this, some series. What is the value? So how will we find out them? That we are going to find out using, is it convergent or not? If convergent, what is the value? That can be done using a special type of series called telescoping series. Very interesting questions are there. We are getting definitely one question in the entrance that we will see in the next class. Okay. Right. So I'm closing here. Sir.
Okay, madam. Thank you. Thank you very much.
Any doubts, ma?
Very nice session. Any clarification, ma?
Don't miss next session. Telescoping series, some 20 to 30 questions we are going to do. Definitely directly you are getting in the entrance. You find in no text, except in some international edition, but solutions not there in that edition. So that those solutions we are going to work out from international edition. Hardly very few people know about telescoping series. You don't know that this is from telescoping series. The tragic situation is you are not able to identify the question, the topic from which the question is given sometimes. So such questions comes under this. Okay. Right. Thank you.
Thank you, madam. Good night, madam. Yeah, good night, all of you. No doubts. Yeah, okay, good. Malikarjun, nice.